Today we are going to start a new concept which is trees. So I hope everyone had heard about trees, but only few have solved few questions related to trees. They would have solved in ADA concept or in other automata concept. They would have solved questions related to this, but the coding part, many of the students have not attended that, not achieved that part, not went into DSA in that part, right? So let's first see what is the definition of DSA. The definition goes like it is a non-linear. So what are the examples for linear? It is a non-linear data structure. What are the examples for linear? Arrays is an example of linear data structure. What are the examples for non-linear? One more example is linked relation. Linked list is a non-linear data structure. So trace is also one of a non-linear data structure, and it will be made up of a node structure. Okay, so in linked list, the node which we refer in linked list is different from the node which we referred in trace. So in linked list, what will happen is this node will be having value here, link here, right? Value, link. But in a node, particular node in trace, we will be having value here, we will be having left link, here we will be having right link. So in this node, the node in trace contains 3 parts, whereas the node in linked list contain only 2 parts. There we had value, which is data, and link. We will just link it like that. But in trace, we will be having value, we will be having left link also, we will be having right link also. So when we start trace, before starting trace, we should know few terminologies, few technical terminologies which we will use. Basically, this is an example of a tree. Okay, 1, 2, 3, 4, 5, like this. It is an just basic example of a tree, and it's not compulsory that a node can have only two subnodes. A node can have multiple subnodes. Suppose this is 6, suppose 6 is 7, and it's not also compulsory that after 2 4, like after 2 3 only should come, after this only should come. The values can also change. To visually appeal guys to understand easily, we will write in this format, but actually how it will be: 1, the value will be here, the left part will be connected to here. That means wait, I'll show here. Okay, 1, suppose here we 1, 2, here we have 3. This is 100, this is 200. Memory location, this is 300. Suppose if this is the thing, this should connect left side to here, right? So here it will contain 200. That means it is connected here. This we have to connect here. Here 300 will be present, which will connect here. Next, here there are no nodes. For this example, for this particular example, we don't have another node here. At that time, we will have null here. So here also we don't have node, null, null, null. So basically, the data will be like this, but for easy understanding, we will write in this format. Okay, if we wrote the same thing in linked list format, we would be replicating the data in this format. But in trees, we will write it like this. So this is an example of a tree. Now I will say few terminologies related to trees. After that, if you are having any doubt, you can ask at that moment itself. So first terminology is root. So root node. What is root node? Here each and every individual circles are a node. Okay. But what is root node? Root node means the topmost node, or we can say a node without a parent node. So a node without a parent node is called a root node. In this tree, there are no parent node. We will see what is parent node. Okay. So basically, if this node don't have any, this is the start. In linked list, where we will start from head, right? So basically, this is a head. Tree's head is called as root. That's it. Okay. Next, we will see parent node. Parent node means, so for 2, which is the parent node, the node which is having this, the tools location, right? So where we are having tools location in here. So this is a parent node of 2. No matter 2 may be connected here, 2 may be connected here, it will be connected something 5, something 6 here. It doesn't matter. The value, this place, this memory location is referenced by which node, that node is called as parent node. In simple words, if 2 is connected previously to a node 1, then 1 is a parent node. For 6, 2 is a parent node. For 4, 2 is a parent node. For 7, 3 is a parent node. For 3, 1 is a parent node. So basically, parent node, you got an understanding. Next is child node. Child node means one is connected with 2 also, one is connected with 3 also. So for 1, 2 and 3 are child nodes. For 2, 6, 4, 5 are the child nodes. For 3, 7 is the child node. For 3, 6, 7 is the child node. For 6, we don't have any child nodes. So number of child nodes for 6 is 0. Number of child node for 2 is 3. Number of child node for 3 is 1. Number of child node for 1 is 2. Okay. A node can, there is one rule, which is a node can have multiple child nodes, but only one parent node. So you can see in this example, take any node, okay, take any node, it can have multiple child nodes. Here 2 can have 6, 4, 5, it is having 3 child nodes. It's not compulsory that it needs to have a children node, but if children nodes are present, it can be in multiple a node can have multiple children nodes also. 6, 4, 5. Here we are having 3. Suppose here we are having 2. Here we are having 2. But for every node there will be only one parent node, because 5's parent node is 2 itself. We can't say 5's parent node is 4 or 5's parent node is 1. For each and every node, there will be only one parent node and there can be many child nodes. And for each node, except one more rule, for each node except root node, will have compulsorily parent node. So except root node, each and every node in a tree will have parent node. Okay. So parent node is also over, child node is also over. Now let's get about sibling node. So if this is a parent, this is a child, then the nodes present at the same level are called siblings. So one's child is 2 and 3. So 2 and 3 are siblings. For 2, what is the child node? 6, 4, 5 are the child nodes. Right? So who are siblings? 6, 4, 5 are the siblings. We can't say 6, 4, 5, 7, 8 are siblings. For 2 as a parent, we are having 6, 4, 5 child nodes. So 6, 4, 5 are sibling. That's it. Let's hang 1 second. Okay. So sibling node means, okay. Next one comes leaf node. So leaf node means a node which don't have further siblings are called as leaf node. Here you can see we don't have further child nodes are called leaf node. So here this is a leaf node, 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 this is a leaf node. So basically a node is having zero child nodes are called as a node having zero child nodes are called as leaf nodes. So we saw what are root nodes. Okay, one is a root node. Now we know this part is a leaf node and this part is a root node. Then what are these called? So these are called as internal nodes. So here 2 and 3 are internal nodes, 1 is a root node, 6, 4, 5, 7, 8 are leaf nodes. Okay. So guys, everyone understood these concepts? If you understood these concepts, I have few questions for you guys. 1, 2, 3, 4, 5. Now say me what are all the leaf nodes. Type and send me what are all the leaf nodes. Three, 4, 5. Yes. So why 3, 4, 5 leaf node? Because we don't have any more children nodes. So what is root node? Which one is root node? 1 is a root node. Yes, exactly. So everyone know what is the next question. Which one is internal node? Shaili wrong, Hemant wrong, Ananya is correct, Adarsh is correct. So 5 is already a leaf node, right? So this is a leaf node. This is a root node. Only the remaining nodes are called internal nodes. That's it. I wanted to show you guys this one. Okay. So if this you got clarified, then we will move to our next concept, which is I'll take this node only as example and explain you. We can have any values. I'm just randomly getting values. You can see it's not in order also. Okay. So height of a node and depth of a node. Many students confuse between height and depth. I have seen many students who are confused between height and depth. To understand more, like 6, 9, 2. Okay. So guys, a height we will measure from leaf node. A depth we will measure from root node. So basically, if you want to find the height of 2, okay, so height and depth are considered like height of a node. So we have to find height of some particular node. So for height of this node, depth of this node. For height of this node, how much we have to consider? How we will consider the edges. Edges means the path. Okay, the path from leaf node. From leaf node, how many paths we have considered? 1, 2. How many edges? 1, 2. This edges means this lines. Okay, 1, 2. So height of this node will be 2. What is the depth of this node? Depth of this node we will count from root. Root is this one. From root, how much? 1. So guys, can everyone give me height and depth of height and depth of node 3? Come on. H is equals to Just give me the height. H is equals to, Shaili, height is from leaf node. From leaf node. So from leaf node only 1. So 1. Depth is from root node. So from root node means here 1, 2, 2. As again try to understand. I will show you by taking this one. Okay. I will show you the height and depth of 5. Okay. Height. So guys, what in simple words, if this is a tree, okay, if this is a tree, where will our goods be? The goods will be here. Where will our like if someone say measure the height, at here we will have leaf, right? Here we will have leaf, here we will have good. So if someone tells us to measure the height of a tree, then what we will measure? We will see the leaf. We will not see the root, right? We will see the leaf. If we are standing here and someone says to measure the height of a tree, at that time what we will do? You will see leaf. From ground to leaf. From leaf to ground, how much length is there? Suppose 10 meter, you will say like that. Someone says you to give me the depth. At that time what you will do? You will see the root. Right, from ground level how much root it is it has been down, that much you'll consider 5 meters something, you'll say that. So remember those words, those key words. In tree we will write ulta, root will be in upper, we will write root up and leaf down, but we have to consider this as root itself, and the below things as leaf itself. When we say height, we have to see from leaf. Where are leaf? Leaf are from below. So what is the height of this node? From down we have to go, which is 1. One step we will go from down, we will get the node. So what is the depth? Depth we have to count from root node. From root node, how many steps we have to go? 1 step, 2 step. So depth is 2. Guys, everyone understood this concept? The difference between height and depth? It's too much crucial, guys. They will just use the word height and use the word depth in questions. Okay. Then I'll ask you guys one more question. Let me see how many of you will answer it. I hope everyone answers it, but let's see who will answer it first. I'll just write 3 numbers, okay? I'll not circle it. Okay, now give me height and first give me height of 5. Guys, jaldi fast give me height of 5. Oh, very good, very good. What is the depth of 5? Oh, shift to depth. Depth 1. Excellent. So if I write 12 here. Now, what is the height of 5? Come on, guys. What is the height of 5? So now it's interesting, right? Now it's interesting. Because we are having, this is also a root node, this is also a root node, this is also a root node. From this root node, we will have only 1 step. From this root node, we will have 2 steps. From this root node, we will having 3 steps. Now, which one we should consider? Should we have to consider this 1 step? Should we have to consider this 2 steps? Should we have to consider this 3 step? Again, let's go back to our tree. If we are having leaves, 1 leaf is here, 1 leaf is here, 1 leaf is at the top. So, which one will you consider? Will you consider the lowest one? The distance between, suppose this is A leaf, this is B leaf, this is C leaf. A leaf, B leaf, C leaf. So now if I ask you the size or the height of a tree, which one would you say? Would you say A, would you say B, or would you say C? Which one would you say? C, obviously. Why? Because this is the longest. Till here we are having the tree, right? Till here we are having the tree. So which one is the longest among the length? That one we will say as a height. So basically now, according to this leaf, the height is 1. According to this leaf, our height is 2. According to this leaf, our height is 3. So what is the actual height of our 5? Come on, guys. Anya is very good. Anya, very good. Shaili, Sandha, Hemant. Exactly, guys. So now you got the confusion. Now the confusion is resolved, right? So tree is bit confusing because we will call the uppermost node as root node and the lowermost node as leaf node. So that's why we have to, like, it's all reversed. So we have to, every time, each and every time, if you get confused, remember this tree and remember my drawing also. Okay. So guys, if you are, everyone's got this right. Everyone are okay with terminologies. So okay, what are in this root, in this tree? What are all the leaf node without excluding any leaf node? Comment. Okay, write all the leaf node. Let's see who will write it. 3, 4, 10, 12, 11, 6. Exactly. Yes, Shaili got it first. So guys, now a root node is 1 itself. Now write all the internal nodes. Let's see who will get it. Internal nodes. Only internal nodes. 2, 5, 6. Wrong. 2, 5, 6, 6. 6 is root node, right? You have already written 6 in root node. 2 and 5. No. No one gave a right answer till now. Again wrong. 2. Okay, wait. 2. Oh, so sorry guys. Here also we are having 6. Here also we are having 6. That's why I got confused. This node is internal node. This node is internal node. This node is internal node. This node is internal node, and this node is internal node. If you are saying these nodes, then good. Let's move to next concept. I have written duplicate values. That's why it's okay. So now you guys are perfect with the terminologies related to trees. Our next topic is types of trees. So our first type is okay. Before going to types of trees, we have to complete one more concept, which is again a simple concept. So there is a one particular tree called binary tree. What is binary tree? It has few rules. So each node have at most 2 child nodes. So each node can have only at most 2 child nodes, maximum 2 child nodes. A node cannot have more than 2 child nodes. If all the nodes of a tree satisfies that condition, then that complete tree is called as binary tree. This is the criteria to consider a binary tree. And in DSA, most of the cases we will solve using binary tree itself. Like we will use binary tree itself. So, for example, if we are having 1, 2, we will have something here, something here, something here, something here, something here, and something here. So guys, is it a true binary tree? Can we consider it as a binary tree? No. 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 Yes. Why? Why? Because this root node has three child nodes, but it is not possible. A node, each and every node should have at most two. If a node has having more than two child nodes, it is not considered as a binary tree. If a node has, so guys, assume we are having only the root node. We don't have any node itself. We have deleted all the nodes. We are having only the root node. At that time, is this considered as a binary tree? Everyone are wrong. So what is the condition, guys? Each node should have at most two child. So at most means what? We can have two. Okay. We can have one. Okay. We can have zero. Okay. So maximum is two, right? Minimum, we don't have any condition. So for this node, how many nodes, child nodes it is having? It is having zero child nodes. It is acceptable, right? So as if you are having only a root node, then also it is considered as a binary tree. If you are having only like this, if you are having a tree like this, then also it is considered. If you are having a tree like this, if you are having a tree like this, then also it is called as binary tree. Why? Because each node can have at most two child. At most means maximum two child. Minimum can be zero. It can have no child also. It can have single child also. It should have two child. It should not exceed two. If it exceeds two, if anything has 3, 9, if like this, if any node have, at that time it is not considered as a binary tree. Apart from it, any tree having at most two child nodes is considered as binary tree. I hope you all understood what and all trees comes under binary trees.